Hi, in this video we will compute gravitational acceleration inside the earth using Gauss law. Okay, so first let's discuss Gauss law. Okay, Gauss law says that the total flux through a closed surface is proportional to the inside mass. Okay, mathematically the total flux G dot ds integration over the closed surface equal to minus 4 pi g into mass inside the closed surface. Okay, where g is the gravitational field. Okay, so how we define the gravitational field? Let's say we have two mass, capital M and small m. Okay, so if with the force experienced by the small m due to the mass capital M, then F equal to mass times gravitation acceleration. Okay, so G equal to force by mass m. Okay, I should mention here that the small mass should be very small compared to the capital mass, because it should not affect the field produced by the mass capital M. Okay, now let's apply the Gauss law to find out the gravitational acceleration inside the earth. Let's say we want to find out at the depth d. Okay, in order to do that, at the depth d we have drawn a hypothetical concentric spherical surface. Okay, so if m in be the inside mass in this spherical surface, then the Gauss law will be g dot ds equal to minus 4 pi the gravitational constant g times inside mass. Okay, so this is equal to magnitude of g times ds into cos theta, right, where theta is the angle between g and ds. Okay, equal to minus 4 pi g into mass inside. Okay, now the magnitude of the gravitational acceleration g is constant everywhere on the surface. Okay, and the direction is radially inward, because if we put any mass on the surface it will be pulled downward, right? And the direction of the ds, which is the surface element of the surface, radially outward, right? So the angle between them is pi. So we will have minus g into ds equal to minus side. Okay, we pulled g outside of this integration because g is constant everywhere on the surface. Okay, so we will have g times 4 pi r square, because the area of the surface is 4 pi r square, right, where r is the radius of the surface. This is equal to 4 pi g into m inside. Okay, so we will have g equal to capital G m inside by r square, right? Now in order to find m inside, let's assume rho is the mass density. Okay, so 4/3 pi r cube times the mass density rho, that is equal to mass of the earth. Okay, so rho equal to capital M by 4/3 pi r e cube. Okay, so mass inside will be, that is volume times density. Okay, if we put the expression of rho we will have capital M times R by RE whole cube. Okay. So if we put the expression of M in, so we will have G equal to, here G is the gravitational constant and M is the mass of the earth and R is the radius of the earth. So this term is constant, right? Therefore, G is proportional to the R. So in other words, inside the earth, G will increase linearly with R. Okay. And on the R surface, that means R equal to capital RE, G will be, let's say this is G naught equal to G into capital M by RE square. Okay. If we express G in terms of the depth D, then G will be by RE cube into RE minus D. Okay, because this radius R is RE minus the depth D. This is equal to 1 minus D by RE. Okay, this is equal to G naught times 1 minus D by RE. Okay, so when we go inside the earth, the gravitational acceleration G decreases linearly with the depth D. Okay, similarly we can find out the gravitational acceleration outside the earth using Gauss law. Okay, in order to do that, we will draw a spherical surface at the height h. Okay, so in that case R equal to RE plus h. Okay, and M inside will be mass of the earth. So the gravitational acceleration will be G equal to G M inside by R square, that is equal to G capital M by R E plus H whole square. Okay, so for small height, that means H is much smaller than RE. We can write this as okay, as H is much less than RE, so H by RE is much smaller than 1. Okay, so we can expand binomially and we will have 1 over RE square times 1 minus twice H by RE. Okay, so the gravitational acceleration will be G equal to times 1 minus twice H by RE. Okay, so this is equal to G naught times 1 minus twice H by RE. Okay, so the gravitational acceleration decreases linearly with the height h. But remember, the height is very small compared to the earth radius. If we draw the plot G versus R, then inside the earth G increases linearly, that is G is proportional to the R, and above the surface it decreases as 1 over R square. So it is proportional to the 1 over r square. Okay,